Does the thought of traveling from Kalamazoo to Sydney in less than 2 hours intrigue you? If it does, then look no further than the Scramjet. The Scramjet is an air-breathing engine integrated into the airframe. Air breathing implies there are no moving parts. This allows it to operate at higher speeds than a conventional jet engine. As supersonic air enters into the Scramjet engine, it's compressed by the geometry of the engine. After fuel injection, then combustion, thrust is produced. Currently, flight tests are conducted by attaching the Scramjet to a rocket, the rocket to a B-52 bomber. The bomber brings the rocket up to altitude, releases the rocket, and then the rocket brings the Scramjet to its operating speed. In addition to high-speed travel, the Scramjet has applications for high-speed missiles and space access. Some of the challenges that are preventing further viable development of the Scramjet are, as the speed increases, so does friction. Friction produces drag, drag reduces thrust. Second, have you ever tried to maintain a lit match in a hurricane? Well, I assure you, it's difficult. Likewise, with the Scramjet, sustaining combustion in a supersonic airstream is difficult. Despite these daunting challenges, I thought it worthwhile to pursue research on Scramjets. In doing so, I investigated potential solutions to these challenges. In regards to skin friction drag, consider that as air flows over a surface, a thin layer develops, called a boundary layer. If combustion occurs within that boundary layer, that will reduce the skin friction. I've conducted numerical simulations to support this that have been validated. Second, in regards to sustaining combustion, a possible means is to stabilize a detonation wave. I've conducted numerical simulations that show a stabilized detonation wave, which support this proof of concept. I'm confident that these results will assist in the further development of the Scramjet, and in the near future you will be able to fly from Kalamazoo to Sydney in less than 2 hours. Thank you.